Welcome, everybody. Thanks so much for coming out and joining me today. My name is Brandon Minnick, and in this session, we'll be talking about an introduction to serverless with AWS Lambda in C#. I'm so excited to be here talking with you today about serverless because it's a topic that's actually near and dear to my heart. I'm actually a mobile app developer. I've been creating iOS and Android apps in C# using Xamarin and .NET MAUI for 7 or 8 years now. And I've published a couple apps at the app stores, and I do it for fun in my spare time. So the apps I have in the app stores are totally free to download. I don't make any money off them, and I'm the only guy working on them. And that's the reason I love serverless, because with serverless, every mobile app needs a backend. Well, I can use serverless tools like AWS Lambda to easily, quickly spin up a backend for my mobile app. I don't have to worry about maintaining a server. I don't have to worry about security patches. AWS does that all for me. And one of the biggest benefits of serverless that we'll be diving into is also just the cost. It's super, super cheap because serverless only runs when you need it to run. And if you've ever used any cloud providers, they charge you every time you consume anything. So any CPU cycles, RAM, server space, internet bandwidth going in and out, you're going to get a bill for that. And with serverless, my monthly bill is super, super cheap. So for someone who just publishes apps to the App Store for fun in nights and weekends, and I'm the only one working on it, being able to use tools like serverless is big, big, big help. So before we get rolling today, I do want to highlight there are 2 links that you'll see at the bottom of just about every slide today. On the bottom left here, that is my Twitter handle. If you ever have any questions, or maybe we didn't get a chance to chat after the talk, I will be around the rest of the day at the .NET on AWS booth. But feel free to shoot me a message. My direct messages are always open if you ever have questions about C#, .NET, AWS, mobile, whatever it might be. Always happy to chat. And on the bottom right here, this is a web page that I've put together for this session today. And this is where you can find everything we're going to talk about. So don't worry about memorizing anything. You can just sit back and relax, because on this webpage is where you can find these slides. It's where you can find a recording from this talk. It's where you can find a link to the code we're going to be checking out. It's all open source. It's available on GitHub. And I've also included links to helpful articles and getting started and blog posts. So if you're brand new to Lambda, you can find it all there. So you can either go directly to the link, scan the QR code, it'll take you to the same place. And if you have any friends or coworkers who maybe couldn't make it today, you can also send that to them, and they'll be able to get up to speed even though they're not here with us today. Okay, so what is serverless? Well, it's kind of a funny word, because serverless implies no servers, and that's just not true. That's not possible. Our code is running in the cloud, and laws of physics say we've got to be running on a server. There's got to be a CPU, there's got to be some memory. So there's really no such thing as serverless. And I find that a better way to describe it is less server. There's less server for us to worry about. There's less server running, so we don't have as much to pay for at the end of the month. And what I've really found, though, is to really understand serverless, let's go all the way back. Let's go back into the day, because I don't consider myself that old. I've been doing this for about 15 years now. But when I first started in the industry as an engineer, everything was on premise. The first company I worked at, we just had massive, massive data centers where if we wanted to run anything, well, step one was we had to go buy a server. And even before that, we had to plan months in advance to kind of figure out, like, okay, well, what application are we building? How many users are we going to have? How much load do we expect this server to need to be able to handle? So we would spec out everything, and then finally we'd be able to order the server. So that would mean I'd go to the procurement office, and I'd say, hey, we figured out I need a Server was 64 gigs of RAM, 16 core CPU, and they would order it, and about 6 to 8 months later, a server would show up on my desk. And then once that server showed up, I would walk it down to the data center where we'd have to badge in. We have a team of physical security to make sure that nobody that didn't have access to the data center was allowed in. And I'd go in and I'd find a rack that was open. I'd slide the server in. I'd bolt it into the place in the rack, connect all the Ethernet cables, the power cables, make sure you have 2 power supplies in case one burns out. Make sure you have redundant hard drive RAIDs, just because your hard drives are gonna need to be replaced. I've replaced so many hard drives in my life because of that. And then once all that's done, now I have to install the operating system. So now I've got to figure out which version of Linux are we going to use, what are all the compatibilities, what are all the security concerns. So now I'm chatting with our security team to make sure we lock down the ports and only open up the ones we need. Make sure I'm talking to our sysadmin team to make sure that we're up to date on the latest, greatest version of Linux. And then finally, after all that was done, we could start working on our app. So that was just how it was. Cloud didn't really exist, but what this meant was just to write an app, just for us to write some code, publish it to a server, and be able to have an app that our customers use, we have to plan months and months in advance. And even on top of all that planning, there's even things like redundancy. So what if that server goes down? So maybe we should have 2 servers and one to back up the other one in case that first one breaks. But what about if the data center goes down? I used to live in Florida. Florida gets hit by a lot of hurricanes. What if a hurricane comes through, blows the roof off? That actually happened once, and we lose that server. Well, I guess we'll buy another server. We'll do the same thing. We'll ship it up to the other data center in Washington, D.C., and great. Okay, now we can run our app. So yeah, with on-premise data centers, there's just tons and tons of overhead, tons of pain points, and also we need just teams and teams of people. Folks like me who just want to write code still need teams of system administrators, network administrators, physical security, computer security. So big pain points with on-premise. But shortly afterwards, or shortly after I started, Amazon kind of realized, well, wait a minute. We also have massive data centers with lots of servers in there. And we look around, not all of these servers are being completely utilized. We paid all this money for servers. They're not all running at max capacity 24/7. So what if we rented out some of that server space? And this is where the concept of cloud infrastructure came up. So the first step into creating the cloud was to basically allocate portions of existing servers that Amazon was using to us. So now, instead of me having to spec out how much server I need, how much RAM, how many CPUs, having to go and order it and wait for 8 weeks for this server to arrive, with cloud infrastructure, we could just go to AWS and say, hey, AWS, I think I want a 16-core processor and 64 gigs of RAM. And they would use the concept of virtual machines to essentially partition part of their existing servers and let us essentially rent it. So we could do whatever we wanted with that server. And that's great, because now we can get up and running in no time. So now I don't have to worry about redundancy, because AWS is going to take care of that, make sure my virtual machine's always up and running. I don't have to have a giant data center. I don't need to have work at a massive corporation that can afford to maintain all that infrastructure. We can just, with a couple clicks of the mouse, spin up a virtual machine, which virtual machine, if you've never used them, it's basically allows you to partition a server into multiple servers, essentially. So you could have one physical server where you could allocate a couple CPUs and a little bit of RAM to run Windows. You could allocate a couple other CPUs and a little bit of RAM to run Linux. And so you could have multiple servers running on one server with virtual machines. And that was kind of the birth of the cloud. And this is great. So now I can get up and running right away. But they just gave me a virtual machine. I still had to worry about the operating system. I still had to keep the operating system up to date, install security patches, enable ports, disable ports. We still had to have that network engineering team, system administrator team. We still had to have a whole team of people just to maintain this server. But the benefit was with cloud infrastructure, we didn't necessarily have to go through all those hoops of ordering it ourselves and maintaining it ourselves and racking and stacking in our own data center. But then along came this concept of cloud platforms. So if you've ever heard of tools like Elastic Beanstalk on AWS, this is what we're talking about, where instead of having to worry about the operating system level stuff, AWS kind of figured out, hey, what if you just tell us how much server you need? So I would go to AWS and say, hey, I want 16 gigs of, or 16 core CPU and 64 gigs of RAM, and here's my code. And they go, great, okay, your code's up and running. And for us as developers, all I had to do was right-click on my C# project in Visual Studio, say publish to Elastic Beanstalk, and now my code's up and running, and they've allocated all those resources for me, and they've got their team of people handling everything underneath. So all the operating system stuff, keeping it patched, keeping everything secure, keeping out the hackers, keeping the ports, keeping the routing, all that stuff's taken care of for us now. So with cloud platforms like Elastic Beanstalk, we don't have to worry about that anymore. We just have to make sure that we have enough server so that our user demand doesn't get too high and overload it. Now, you can always scale up. You can tell AWS, hey, if my CPU hits 90% capacity, add on another server and just kind of start duplicating things, and you can scale up with it. But we still want to keep an eye on that. And the other thing with these cloud platforms like Elastic Beanstalk is we're still renting out that server space. We still told AWS that we want 16 core CPU and we want 64 gigs of RAM, and they're going to give that to us. And whether we use it or not, we still got to pay every month for that bill because nobody else can use it. They've reserved that space. And with that idea in mind, came along, finally, the concept of serverless. So serverless, same idea. I don't have to worry about the operating system. I don't have to worry about security. I don't have to worry about redundancy. All that's taken care of for me. But where serverless builds on top of cloud platforms like Elastic Beanstalk is that now serverless, we don't even have to care about how much server we're going to be using. So I never tell AWS that I need 16 cores of CPU and 64 gigs of RAM. With serverless, I just write my code in Visual Studio, I right-click on my C# project, and I push it to the cloud, and they will automatically scale up and down as the users demand. And so what's really cool is if, let's say, I have 100 users using my app all at the same time, it'll scale up. If I have 1,000, if I have 1,000,000 users, they'll handle the load for me. And then let's say it's nighttime. Let's say all my users are asleep. Well, it'll scale all the way back down to 0 so that if nobody's using my app, I don't have to consume, I don't have to reserve any resources from AWS. And what this means is at the end of the month, you don't have to pay for that. So your bill ends up being really, really small. And so when you think about what I was working on with my mobile apps, again, just do it for fun in the nights and weekends. I don't make any money off them. And so serverless is not only the cheapest option, but it's the easiest because there's really nothing for me to maintain. I know all the server stuff, all the operating system stuff, that's all managed away, and I don't have to worry about it, thanks to the folks at AWS who are smarter than me. Now, so again, like why would we want serverless? Well, you don't have to worry about the servers anymore. So never have to worry about security patches. You never have to worry about any vulnerabilities. You never have to worry about redundancy or like power supplies going down or hard drives going down. It abstracts away all of that from what we need to do and what we want to do. And with serverless, we get instant scale. So like I mentioned, if we have 100 users, if we have 1,000 users, if we have 1,000,000 users, it'll scale up to handle that. And then if nobody's using our app, maybe everybody's asleep, it'll scale all the way down to 0 when idle so that we're not paying for resources that we're not consuming. So it really optimizes our bill at the end of the month. Now, here's the catch, because there's no such thing as a free lunch, right? Like, this all sounds great, and it is great. I love it. But because those resources scale down to 0, we introduce this concept of a cold start time. So what this means is if nobody's using my app, those resources scale down to 0. But let's say you're the first person to wake up in the morning, you launch the app, so what AWS has to do is quickly allocate those resources and spin it up in the cloud, and that takes time. And right now, on .NET 6, we're seeing about 900 millisecond latency in what we call cold start times. Maybe that's a lot to you, maybe it's not. I've personally found 900 milliseconds not that big of a deal. But this is what we want to keep in mind when we're thinking about, do we go with something like serverless, or should we reserve that server space and use something like Elastic Beanstalk, where we have that server, it's running 24/7, it's always live, we'll always get quick response times. Now, I do want to mention, these cold start times are a huge, huge focus for the serverless team. So every year, these cold starts are getting lower and lower. These times are getting faster. The numbers are getting lower. And what we can see here is even now with .NET 7, the cold start times, especially with AOT, are getting down to about 200, 300 milliseconds. And that's literally a blink of an eye. Like, the human eye takes 300 milliseconds to blink. So for most folks, that should be totally cool. I know for my apps, I've never gotten a complaint, but I'll fill you in on a little trick that I do. So if you download one of my apps from the App Store and you launch it, you'll see you get greeted with these little fun animations. So it kind of distracts the user while the app is reaching out to the serverless backend, and maybe there's a cold start, maybe there's not, maybe we get a warm start. But the user doesn't realize it because they're distracted. And this is proven. This is something I learned back in a psychology class back in college, where there was a story about there was this office building that had elevators that were really, really slow. So this building manager kept getting complaints from everybody in the office that, hey, I'm being late to meetings. You know, the elevators take forever. Can you fix it? Can you fix it? And they couldn't. I forget if it was just a safety thing or if they didn't have enough money. But what they ended up doing was, instead of making the elevators faster, they installed mirrors next to the elevator. So instead of just pushing the button and kind of standing there waiting for the elevator to come, checking your watch, now folks are looking at themselves in the mirror, because let's be honest, we're all vain, right? We're going to check our hair, make sure our clothes are looking good for the meeting with the boss, and then next thing you know, the elevator's here. And all of a sudden, all the complaints went away just because it felt like the elevators were coming faster. So again, keep this in mind when you're planning out your architectures. Are there ways that you can work around it? What are the limitations? I guarantee you there's folks that here work in finance. Maybe you're doing stock transactions where, if you don't buy and sell that stock within 10 milliseconds, then you're going to lose money. Okay, yeah, serverless probably isn't the right path to go for you. That's totally cool. But yeah, if you can deal with a couple hundred milliseconds latency, you're gonna be in a good place. But I will say, there is this other concept called a warm start, and this means that the resources have already been allocated and our serverless backend's already spun up. So if we go back to the example, like everybody's asleep and I'm the first one to wake up in the morning and launch my app, well, I'll hit that cold start penalty. But then let's say you open the app a couple seconds later, a couple minutes later, well, all those resources are warm, and they stay warm for about 10 minutes. So every user that comes after me doesn't get hit with that cold start penalty. They experience what's called a warm start, and now we're talking 10 milliseconds, which is basically negligible. So keep an eye on these numbers. I've posted these to the website here, and if you go to codetraveler.io/NDC-Lambda-intro, you'll find this chart. Click on the chart, and it'll actually take you to the GitHub README where we at AWS keep these numbers updated. So stay tuned for .NET 8, but what I'm excited about is this concept of AOT here. You can see this like dramatic difference between non-AOT and AOT. And if you've never heard of AOT, it stands for ahead of time compiled. So you may not know this, but .NET actually uses a JIT compiler, just-in-time compiler. And that's really, really cool because if we're running a web server, so we've got a dedicated server, we're running a website on it, and that website serves hundreds, thousands of customers a day, it's always up and running 24/7. Well, the JIT compiler is really cool because as our code runs, it optimizes it. So we get some free optimization from the original .NET JIT compiler. But when it comes to serverless, well, our code's only going to be running for a short period of time. Those resources are only allocated for about 10 minutes. And so what we want is actually a ahead of time compiler. We want those optimizations done before our app even launches. So in .NET 7 is when the team introduced this concept of native AOT. They still kind of say it's in preview, but it's not in preview. It's kind of in this weird limbo state in .NET 7, but they've been doing a ton more work in .NET 8. So stay tuned in .NET 8 because I've got a hunch that the .NET team will promote AOT to be stable. They'll recommend it for everybody. And if that's the case, then we're talking blink of an eye, 300 millisecond cold start times for hopefully in .NET 8 using AOT. So I keep mentioning my monthly serverless bill, so I want to share with you the actual stats. So these are the two apps that I have in the App Store. Shameless plug, please download them, check them out, give them 5 stars if you like them. The first one here is called Git Trends. If you're a GitHub user and you have a lot of GitHub repos, I created Git Trends to help me manage my GitHub repos, because I've got a couple hundred open source repos, and I couldn't keep track of which ones were actually being used and which ones were growing in popularity. So Git Trends shows you how many people are viewing your repo, how many people are cloning your repo, how many stars you get. It'll put them together in nice little graphs for you. And then it'll also send you a push notification if maybe one of your repos gets a spike in traffic. So maybe somebody here at NDC was talking about one of your GitHub projects, and all of a sudden, all thousands of attendees are now looking at your code. Well, it'll send you a push notification to let you know one of your repos is trending. That way, at least for me, it kind of tells me, like, make sure you go check the code, make sure everything's still working and looking good, because I've had repos before where I haven't touched them in 2-3 years, and then all of a sudden, get a whole bunch of traffic because somebody recommended it. So that's Git Trends. And then Pun Day. If you're into puns, into word games, I teamed up with a friend of mine who does these fun drawings where every drawing is a pun, and it's like a puzzle. You gotta figure out what is the pun that the drawing's trying to convey. But anyways, enough with the shameless plugs. I've got a couple hundred monthly active users, and I pulled these numbers from my bill. These are my real serverless costs. So for Git Trends, it was about 14 US pennies per month. And for Pun Day, about 19 pennies per month. So very, very affordable, especially since these apps are totally free and I don't make any money off them. And in the fine print down here, I don't know if we can read it in the back, but the billing rate is $0.00001 per gigabyte second. So you get a lot for free when you're using serverless. So highly, highly recommend it. Now, the other really cool thing is because everything happens on demand, right? What we've been talking about is all these resources spin down to 0, and then there's something that triggers it, something that wakes it up. And I haven't said it explicitly, but all the examples I've been talking about so far have been talking about these HTTP triggers. So using serverless for an API. They work great. That's what I use for the majority of my serverless applications. But if you have resources in AWS, so for example, S3, that's storage. So if you think of it like a big folder in the cloud where you can drop images, you can drop any sort of blobs you want into it, you can actually trigger a serverless function to run anytime something new is added to that bucket. And I'm going to show you a demo in just a minute of an app I've created that demonstrates that. But just so you know, there's a trigger for just about everything in AWS. So things like DynamoDB. Maybe you add a new document, like a new user signs up for your website or for your app. So we add a new user to our DocumentDB database. Well, we can have a serverless function kick off right as soon as that document's added to maybe send them a welcome email. So now we don't have to have somebody manually going through the database every day or once a week and going, okay, who's the new users? Let's send them a welcome email. We can kind of set up these event-driven serverless functions to automatically do it for us. So really, really cool, really, really helpful. But I'll tell you what, enough talking about it. Let's actually jump into this sample app that I've made for us today. Now, so like I mentioned, I'm a mobile app developer. So I've gone ahead and created a mobile app in C# using .NET MAUI that takes a picture. And then I have 3 serverless Lambdas set up on AWS. So the first one, we upload that picture to the cloud. So I have a HTTP trigger that's essentially acting as a post API where I upload the photo. And all that does is save that photo to S3 storage. So it drops it in the bucket. And once that happens, that upload image, that code is done running. It doesn't care what happens after that. It goes, all right, save the file to a bucket. Let's move on. But then I have this S3 trigger, which is always listening to S3. And anytime a new file is added, well, that function wakes up. And in this case, what we're doing is we're generating a thumbnail. So this is a super, super common use case. So you may or may not know, but pretty much any mobile app where you take a picture and you upload it, so think of, anything from like Instagram, Facebook, they don't actually hang on to that original photo because phones nowadays, like the new iPhone has something like a 48 megapixel camera. So could you imagine if I upload a 48 megapixel image to Instagram, and then every time you guys come look at my profile, Instagram serves you back that 48 megapixel image? It'd be massive. And not only would the app be super slow to load, but they'd be paying crazy amounts for bandwidth costs trying to serve up all of those images. So yeah, pretty much every app nowadays, when you upload a photo, they'll automatically scale it down. So like Instagram will scale it down. They'll make like a 1080p version, a 720p version. That way, they can serve you a photo that still looks good on your phone, but it doesn't have to be that same huge, massive photo that I created, that I gave to them. So that's what we're doing here. So this S3 trigger, as soon as that file's added, it'll automatically generate a thumbnail. It scales down that image to a 200 by 200 pixel photo, and then adds it back to the bucket. And now, when the mobile app goes to request the image, so when it says, like, give me the latest images, it gets served this 200 by 200 pixel image. So let's check it out here. I've got, let's see. So I've got my Android phone right here. And let's launch this. It's called... So it's called Lambda Triggers Sample. And again, you can find the code. It's all open source. I've posted it on the website. So what I'll do, I'll go ahead and take a photo. There we go. And now that photo is being uploaded. So we've got our first serverless function waking up, storing that to the S3 bucket. As soon as it's added, this S3 trigger will wake up, generate that thumbnail. And then as soon as it's put back in the bucket, then our mobile app will be able to get just the thumbnail image back from the cloud. So I do have the photos stretched out a little bit, so it almost looks like it's the same size. But you can kind of see I'm a little blurrier in this one than I am in this one. So let's actually take a look at this code and check out what's actually going on here. Okay, so step one, let's zoom in a little bit. Let's hide some things. There we go. So, actually, you know what? Nah, we'll keep going with this. Okay, so the first thing I want to point out is when you're getting started with AWS and .NET, we've got a plugin for Visual Studio. So this over here is my AWS Explorer, and this is an extension that you're going to want to install right away. So I've included a link to it on the webpage, but this is called the AWS Toolkit for Visual Studio. So make sure to come in here, add it into Visual Studio, because it makes your life so much easier, because now we can actually manage everything in the cloud here on the left. So for example, here's my AWS Lambda functions here on the left, and we can do cool things like, we just generated a thumbnail. So if I look at the logs, let's see, do we have the latest, greatest logs yet? There we go. So we can see this one ran just a couple minutes ago, and things like uploading the object to S3, upload succeeded. There should be a checksum there, but it doesn't include the checksum. So we can easily keep track of everything we're doing in AWS once we have this toolkit installed. And then the other really nice thing is when we're done writing our code and we want to publish it back up to AWS, so maybe we tweak something, we can just come in here and say, we can right click and just say, publish to AWS Lambda, fill out a couple settings, and then once we click upload, Visual Studio is going to compile our code, it's going to upload our code, and then we're done. Basically, happy days, right? We don't have to worry about anything anymore. So let's take a look at what's going on here. So I've got a couple projects, and one of the cool things is, so this is all the same solution. Because it's all written in .NET, I can share some code between my mobile app here, which this is all written in C# using .NET MAUI, and then I have all my backend code here, and we can share some of the code in between, so I don't have to worry about duplicating anything or worry about bugs popping up or anything like that. And let's first look at our get API. So there we go. So the way you want to think about the code you're writing for your serverless functions, and the reason I keep saying serverless function is that's basically all this is. This is basically just one method. Like if I shrink this method down, that's it. I've got a dispose method here, and we've got our main method, but all the code I've written is here in this method that we've called function handler. And what we put into this function handler, in this case, this API gateway HTTP API v2 proxy request. It's a lot of words, but basically this is our HTTP trigger. And if we were using S3 triggers, we'd see this as an S3 event, and I'll show you what that looks like in a minute. But basically, this is what's coming in. This is what's waking it up. And this is then where we can process that HTTP request. So if you've ever made an API before, you're probably familiar with getting in an HTTP request and then handling it. So what we're doing here is first, like good developers, we got to check to make sure that this request has the right query strings. Like the query string is how I'm passing in the title of the file. And if for some reason it doesn't exist or if that file name is null, then we'll just return, this is an HTTP response. I mean, technically it's, what's that, API gateway, HTTP API v2 proxy response. But we just send back a response that says, bad request. We're missing query parameters. We don't know what to do with this. But if we got it, then we just have a couple lines of code here. So I've created a file called S3 service. I'll show you what this looks like in a second, but where we name the file. So all I'm doing here is taking whatever you called the file, and I just say underscore thumbnail. and that's my secret way of keeping track of what's a thumbnail and what's not. And then what I do is I generate a URI for that file as well, because what's cool with S3, remember I was saying earlier that everything, all that security stuff, that's all taken care of for us by Amazon, by AWS. So what that means is if I upload a file, that file will exist in S3, and technically there's a direct URL to that file, but nobody can access it. And so if we want to share that link, then we have to create a special little file URI. And again, I'll show you that code in just a second. But basically, all we're doing here is we're just retrieving that thumbnail. So we're figuring out what the thumbnail's name is, then we're creating that URI, and this is basically just our GET request. So it's returning back that thumbnail, assuming it's not null. If we can't find it, I'll say we can't find it. But if we can, then great. I'll serialize that URI and send it back. Now, just to show you what some of this code looks like. So this is just a little helper class I made because I've got multiple AWS Lambdas all kind of doing the same thing, right? They're all using S3. So I've got a file here called my S3 service where AWS has this cool thing called an Amazon S3 client. And this is actually provided to us. So as long as I can pass this in, which it's provided to us from our, I'll show you where that came from real quick. Back up. There we go. So when we just initialize Amazon S3 client in our code, because this code is already running in the cloud, this object initializes with everything we need. So you can kind of see here, it says it a little bit in the IntelliSense, but it includes our credentials. It knows what profile we're using, EC2 instances, and so that way we don't have to worry about re-authenticating. We don't have to worry about how do we talk between Lambdas and S3. That's all basically done for us. So if we go back to that S3 service, there we go. So as long as we have that S3 client, then we can grab whatever content we want to upload to S3. And in this case, we're using photos, so these are all memory streams. So if it's a stream, we got to handle a little bit differently. We want to make sure we put it in as an input stream. If it's not, like maybe it's a text file, then we can just serialize it, send it off as JSON. But all that code to take that content and upload it to S3 is just using that Amazon S3 client, and I just say put object async, and it'll just boop, dump it in there for me. And then once I've added that to my S3 bucket, like I said, we'll have a direct link to it, but nobody's going to be able to use that direct link. So what we do is we create what they call a pre-signed URL, where we basically create a custom URL that I can give to you, and it allows you to access this file for a certain amount of time. Now, this is just a sample app, so I figured, heck, I'll let you access that photo for a year. But there's certain apps, like if you ever crack open, I mentioned Instagram earlier, if you ever crack open the app and look at some of the source code in it, or if you go to Instagram.com and you go to use the dev tools to inspect what's going on, you'll see all these pre-signed URLs in it. So again, these are just ways to ensure that people don't have unlimited access to all the files, and you can always cut them off after a certain amount of time. But right, so we put that object in S3, we generate that pre-signed URL, and that's basically it. I just make sure that the response is, well, if it is not HTTP okay, then I'll throw an exception. But that's basically all we got to do. So this S3 client takes care of a lot of stuff for us here. And likewise with just getting that file URI, same idea. We just look to see, does that file exist? So I've got a little helper method where I do a little try-catch block to avoid anything failing to see if I call get object async on my S3 bucket, is that file there? If not, I'll return false. But if it is there, then we can just generate that pre-signed URL, and we're off and running. So, speaking of, let's show you. So let's say we've never created a AWS Lambda before, right? So after we install the AWS toolkit, then we can come into here, and you can kind of already see them because they're saved in the cache for me. But if we just search for AWS Lambda, then we can see all the different types of Lambdas that we have templates for. And there's a bunch. You can do F#, you can do C# with tests. But just to show you, if I select, no, I don't want Node.js. There we go, C#. So if you select one, you'll be greeted with all these options here. So like this is how I got started. Because for example, I wanted to create an S3 function. So if we select that, then we'll add this project to our repo, and looks pretty familiar. It's got, now we've got a bunch of comments and everything's done really nicely. All the stuff that I deleted in my code. But at the end of the day, this is just a method. This is just a function that's going to run. And this is something that is another core thing to keep in mind when we're talking about serverless. So we mentioned cold start times are something we want to keep in mind, that we might get hit with a little bit of a penalty. How do we adapt to that? Is that okay? Well, the other thing is that these are not meant to run for very long. And that's why it's literally just a method. This is why we're not necessarily creating new classes and doing anything that's long running, because the whole idea behind serverless is to have this event-driven backend. So let's do something once, let's get in, let's get out, let's finish it, so that we can scale down all those resources and we don't have to have our code running 24/7. And there is a time limit. I forget exactly how long it is off the top of my head, but let's say 5 minutes or 10 minutes, that if your AWS Lambda function is running, let's say 10 minutes. Let's say your AWS function's running for 10 minutes, Lambda will actually shut it down. So if you go too long, if you're trying to do too much, or you're trying to wait, or maybe you got some deadlocks because you wrote some bad async and await code, Lambda will actually terminate it. So everything we're doing here, make sure it is getting in, getting out, it's doing something once, and then you could always hand it off. That's the other cool thing with the fact that functions scale up, scale down. Well, they can also kind of fan out, where we can have one function do a couple things. Like maybe it adds something to a database, and then it adds something to S3, and it also adds something to SQS, a simple queue storage. Well, we could have an AWS Lambda for each of those, so that first Lambda is basically fanned out to 3 different Lambdas that then they can do whatever they need to do. So whatever we're doing, keep it in mind. We want to have very short-lived code. Otherwise, it will cut you off. So, all right, so let's see. The last one to check out is we have our upload image code here. And this should look pretty similar, because this is also a API gateway HTTP v2 proxy request. So if we think about it, looking back here, what we've got here is this one. So the upload, where it's going to ingest that file. So if you've ever had to work with images, I'm passing this one as a multi-form data parser. We're parsing the image as a stream. and then uploading that to S3. So it's using that same S3 service that I showed you a minute ago. And that's it. And then once it's uploaded to S3, we say that it saved the photo to S3, return back an HTTP OK. And obviously, if it doesn't, then we'll let them know we got a server error. And again, if we look at our logs here, like for upload image, view my logs, refresh, make sure we get the latest, greatest. There we go. Here's the one we did earlier. And it's those log messages are exactly what we see. So here in the logs, we have uploading object to S3, and that exists There we go. Because I just said logger.log information uploading object to S3. So I didn't have to do anything fancy. This logger is called an iLambda logger. We get it for free, and it's injected into our function for us. So up here we have our Lambda context, and we just say context.logger.log information. Then we can make sure we can keep track of everything that's going on in our app. Okay, so we got a little bit more time. I want to show you, let's actually look at what this looks like in AWS. So go ahead and log in. Where'd it go? Amazon likes to make it a little difficult, or I guess IT likes to make it a little difficult for employees to get logged in. They love credentials and authorization and making sure we're still employees, I guess. So that's a good thing. So we're in the AWS console here. If we go to Lambda, then we can see all the Lambda functions that I've created here. So here's our get thumbnail, our generate thumbnail, our upload image. So let's check out this generate thumbnail, because once we've published our code, like I mentioned a second ago, thanks to AWS Toolkit, when I'm done writing this code, I just say publish to AWS Lambda, and then it kind of handles the rest. You can use the command line. There's other ways to do it, but I'm lazy. I just like to right-click publish. Some people get really mad at me for doing that, and sure, yeah, use CI/CD, be good, be better than me. But let's say we just right-click publish. And once we do that, we come in here, and then this is where we add those triggers. So we can add whatever trigger we want, but what's going to happen is, or what it does, it kind of figures it out for us. So like this generate thumbnail, it's going to look for an S3 event in our code, so we don't really have to worry about telling it where to enter into our app. It'll figure that out for us. And so when we add the trigger, literally, all I've done is I have this S3 bucket that already existed. So I wired it up, connected it to the S3 bucket, and just to show you what this looks like I said, it's just basically, S3 is just file storage. It's just, we can drop anything we want in this bucket, whether it's a text file, whether it's a photo, and this is also where we can see those images that we just uploaded. So let's see, if we say open, it'll block the pop-up. Oh, well, there's me testing it out in the hotel room. Nothing embarrassing about that, huh? I thought that was the one we just did. Oh, that was back in January. Here's probably a nicer looking one. Let's open up that one. Let's make sure we got everything stored in S3. There we go. Got my clothes on, got my hair done, looking good. And like I mentioned earlier, all I do, my secret system for generating these thumbnails, I just say underscore thumbnail. So if we pop open this one, and it's going to block the pop-up. So same, just one's a little bit bigger than the other one. All right. Whew. bring the slides back up. There we go. All right. So that's a little taste of serverless. Like I mentioned, a lot of things to keep in mind when we're creating our serverless applications. Are we okay with having a cold start? What are the latest cold start times? Is AOT for .NET better in .NET 8? I hope so. It looks like they're going to move it out of preview into GA. But keep an eye on all of that and think about ways that, can we cheat a little bit? Can we just distract the user? Like how I show a little fun animation. You can get away with having a little cold start and only having to pay less than $1 a month for your cloud costs. So if you're like me and you don't make a ton of money off your apps, well, hopefully your company does. But if you're doing this for fun in your free time, highly recommend using serverless, because also you're not going to have to worry about managing anything. Once we right-click publish in AWS, once we right-click publish in Visual Studio, AWS handles everything for us. So it's going to keep the operating system up to date. It's going to handle the scaling. It's going to scale up. It's going to scale down. It's going to keep everything patched. You don't have to worry about network security or routing or DNS or anything crazy like that. So if you haven't gotten a chance yet, this is where you can find all the resources from today's talk. So this is where you can find the slides, you can find the recording, this is where you can find the code. It's all open source on GitHub. I've got links in there to help you download the AWS Toolkit for Visual Studio. So everything you need is right there. Feel free to share it with your friends, your coworkers. Maybe you couldn't be here today. And thank you so much for attending.